Electricity has become so normal in our lives that most people never stop to ask where it actually comes from or how it could be produced differently. We flip a switch and the lights turn on. Phones charge overnight. Refrigerators run continuously. Air conditioners start with the press of a button. Behind all of this is a massive network of power plants, transmission lines, and distribution systems designed to deliver electricity to millions of homes, but this centralized system also creates a dependency. When electricity only comes from large power stations, every home must rely completely on the grid. This is why many people have started looking for alternative approaches to small-scale energy production. One concept that appears frequently in these discussions is something known as the energy revolution system. At its core, the idea behind this type of system is simple. Instead of relying entirely on distant power plants, households explore ways to generate small amounts of electricity locally, not necessarily enough to power an entire home, but enough to support certain devices, charge batteries, or reduce the amount of energy drawn from the grid. To understand how this works, it helps to look at the basic principle behind almost all electricity generation. Electric power is usually produced through motion. Inside large power stations, turbines spin at high speeds. These turbines are connected to generators that contain coils of copper wire and powerful magnetic fields. When the magnets move near the coils, the magnetic field around the wire changes. This movement causes electrons inside the copper wire to begin flowing, creating electrical current. This process is known as electromagnetic induction. It is one of the most important discoveries in electrical engineering, and it is the foundation of nearly every generator used today. What makes large power plants different from small experimental systems is scale. Power plants use massive turbines, powerful magnets, and highly engineered systems capable of producing enormous amounts of electricity, but the same principle can be demonstrated with much smaller components. In a simplified setup, a generator can be built using a rotating rotor that holds several permanent magnets. Near this rotor, a coil made from copper magnet wire is mounted in a fixed position. As the rotor spins, the magnets pass close to the coil. Every time a magnet moves past the wire, the magnetic field through the coil changes. This change forces electrons in the copper wire to move. The result is electrical current. In small experimental systems, this electricity is often produced in the form of alternating current because the magnetic field changes direction during rotation. Simple electronic components such as rectifiers can convert this alternating current into direct current, which can be used to charge batteries or power small devices. A typical small-scale system built around these ideas may include several basic components: copper coils that act as the electrical conductor, permanent magnets that create the magnetic field, a rotating mechanism that provides motion, and basic circuitry to stabilize or manage the electrical output. Many of these components are relatively accessible. Copper magnet wire is widely available. Permanent magnets, particularly neodymium magnets, are inexpensive and strong. Mechanical motion can be created in different ways depending on the design. Some small generators use hand cranks for demonstration purposes, others connect to small wind turbines. In certain environments, systems may use water flow, gravity-fed mechanisms, or belt-driven motion from other machines. The key idea is always the same: mechanical energy is converted into electrical energy. But an important point is often misunderstood. No generator creates energy from nothing. It always converts existing energy from one form into another. This is a fundamental rule of physics. Motion becomes electricity, but that motion must come from somewhere. Understanding this is important when evaluating systems like the energy revolution system. The goal is not to replace entire power grids with a single small device. Instead, the concept focuses on learning how energy systems work and how small amounts of electricity can be generated locally. In many cases, the real value of these systems is educational. When people build or study small generators, they begin to see electricity differently. Magnets, coils, and motion stop being abstract ideas. They become real physical components interacting in a visible way. Once that happens, electricity stops feeling mysterious. It becomes something that can be analyzed, improved, and experimented with. This perspective often leads people to explore other aspects of energy efficiency as well. They begin paying closer attention to how much electricity appliances consume. They start thinking about energy storage, battery systems, and alternative sources like solar or wind. Small generator systems often act as the starting point for that exploration. Another interesting aspect is how small improvements in energy awareness can affect long-term consumption. People who understand how electricity is produced tend to be more aware of where it is being used. they become more careful about unnecessary energy waste. They start looking for ways to improve efficiency in lighting, insulation, and device usage over time. These adjustments can reduce the total amount of energy a household needs. The key insight behind the energy revolution system is not simply about building a generator. It is about understanding the structure of energy itself. Energy moves through systems. It changes form, and when people understand that flow, they can begin designing better ways to manage it. Small experiments often reveal the principles behind much larger technologies. The same physics that powers massive hydroelectric turbines can be demonstrated on a small workbench using magnets and copper wire. Once those principles become visible, energy systems start making much more sense, and when something makes sense, it becomes easier to improve. The energy revolution system represents that shift in perspective. Instead of seeing electricity only as something purchased from a utility company, it encourages people to study how electricity is produced and how it can be generated on a smaller scale. This understanding does not replace modern power infrastructure, but it gives people a clearer picture of how energy works and how it can be used more efficiently. If you enjoy learning how real energy systems function and how small experiments can reveal the principles behind modern electricity, consider subscribing to the channel. New videos explore practical engineering ideas in simple, clear language. You can also check the description for a helpful resource that outlines the basic structure and components often discussed when people study systems like the energy revolution system and other small-scale energy projects.